Hello friends, welcome to Eastern Academy. We are discussing about embedded systems as a part of embedded system programming. This is session 13 and we are discussing about DC motor control using PWM. First, we had last session, we discussed about uh, what is PWM. Am I right? So we got a very good idea. We'll just review that a minute and then we go to the today's session. Am I right? So let us get into the a small idea what we discussed about what is PWM. The PWM is nothing. It's just a quite simple concept. That means that I have a switch. Am I right? I have a switch. One minute. Yeah, thanks. I see here. I have 5-volt battery, ground. I connect a signal from here, connect here. Now there's a switch. I can put the switch at 5-volt or 0-volt. And this is the point you are measuring. When the switch is at top, I get always 5-volt. So if I connect a motor here, the motor will be rotating. This is simple connection. Let's say I apply 12 volts and the motor will be rotating. Okay. Let's say this is A and B. Am I right? Now, if I make the switch to bottom, then the motor will stop. That means that it's 0 volts. This is what the very simple. With the switch, you can do only one thing. If you put the switch in top, the motor will rotate. If you put the switch in bottom, the motor will off. That's a very simple concept. Everybody knows that. But how do I control the speed? Then only people have the thought. It's a very simple method. I have a switch. When I put it on, the motor will rotate. When I put the switch bottom, the motor will off. That's all we expect. But if you make the switch on off faster, that is, let's say 1000 times per second, 1000 times per second, then what happened? This motor, since you are doing it 1000 times, means what? We discussed that one on off will take about 1 millisecond. 1000 times means 1000 hertz. So this is what we call it as a frequency, or 1 kilohertz. That's what we discussed last class. If your frequency is 1000 kilohertz, then you on off at 1 millisecond. But the motor is a mechanical device. So it cannot stop and start that fast. So effectively what happened? The motor speed comes down. That is, average voltage comes down. That's why motor settled at the right speed. So that is what we call it as a one single word called duty cycle. So do you understand one thing? When I say that PWM, there are two parameters they will talk. One is what is the frequency. The second one is what is the duty cycle. Now we remove this. We just put a microcontroller. And using microcontroller, you can put a simple word, star out equal to 1. Then it will rotate. If a star out equal to 0, then it will stop. Now you can able to do this command 0 or 1. By giving 0 or 1, you can make sure that the motor rotates or stops. But if you do the other way, for I equal to 0, sorry, while 1, see, out equal to 1, star out. Then the motor is going to be on. Then delay. Then star out equal to 0, off. Then delay. The trick is that by having the delay and the on, you are indirectly you are creating a pulse here, a clock with this time, on time, on time. This time depends on so many factors. What is the clock of the microcontroller? Your clock of the microcontroller could be 10 megahertz or 100 megahertz, whatever it is. So the microcontroller speed is based on clock. That is one. Second thing is your microcontroller can be 8-bit or 16-bit or 32-bit. That decides the performance of your microcontroller, how fast it is. But we are using 8-bit. And let us assume we are using a clock of 20 megahertz. Then this instruction will produce some delay. Am I right? How do you find the delay? How do you find the delay? That's very unfortunate. There is not big calculation at all. Okay, because you're writing a code in C. When it get compiled to assembly language, you don't know how many instructions it's generating. Okay, how good the compiler is. There's so many variables are there. Since you don't know about the code, you have to do trial and error. So what is a trial and error? It's a very simple method. Normally we do that. That is what we do here is quite simple. We go to the, I'll tell you how much time normally we do the timing. How do we do the timing? I'll give you a small idea. How do you calculate the timing? This normally you don't know that, but I'll give you the idea. How do we calculate the time? It's a very same simple circuit, but we are trying to discuss so many things. Understand? Okay, that is fine now. Now let us make a small, as usual, we do a small one. We connect a LED, very small circuit. Takes a minute, but I told you now, I wanted to show you, otherwise I would have drawn already. I want to show you because every time when you do that, you understand something. So we just connected. I write a code here. Let's see how much this is not thing you should do it in no time. We have seen this so many times. Am I right? By heart. By this time you should have been by heart. I'm in a loop. While one, I'm in a loop. Now I'm going to do that star out equal to 1. Then I say for I equal to 0, I less than 1 lakh, or let's assume 5 lakhs. I plus plus, small one. Am I right? Now let us copy this line. I'll tell you how we do calculate. These are the things you may not know that. That's why I'm showing you the same thing. You may be thinking that why I'm doing the same LED blinking, but you can do wonders with this. Now we make out 0. See here. Now I say volatile long I, because I'm using a 32, more than 32 bit, 16 bit. That's why I'm using a long I declare. Now let us run the program. See that? Let us make this program big, that LED big. Now let us make this as a 10 lakhs. That will be easy for us to divide. Now what I'm going to take, I'm going to take my mobile phone. The mobile phone, I'll be using this clock. Let us see that. Okay, now I take the mobile phone and I'm going to have the stopwatch. I start from 0. See here, I run this program. Sorry, I did a mistake. With the light on, I should do that. Okay. You can do any method. This all very logic, common sense. I do this method, you can do any method. See here, when the light on, it takes about 2 seconds roughly. That means that this delay, 10 lakhs, gives me 2 seconds. Now you see that how much time it is on and off. About 2 seconds on and 2 seconds off. So now you write it down in a paper. You should write it down on a paper. $10 lakhs equal to 2 seconds. So if I want 10 seconds, then I make this as a 50 lakhs. See, I make a 50 lakhs. If you make 50 lakhs, it goes on for 10 seconds. Let us see that whether it's correct or wrong. The next time it's on, I will do that clock. See how this is the way you first to do that. I'll tell you why you are doing that. You will know exactly using a software just by minimal instructions. I on that. Now let us see that how much time it takes. It's not so perfect, so it takes more than 10 seconds, about 14 seconds. So I have to calculate now. It is not 2 seconds. It's slightly more than 2 seconds. Now you think of it. Now I make it as another calculation, 1 crore. Now I give a 1 crore, then you will be getting a more accurate result. See that. If you make it as a 1 crore, then let us see that how much time it takes. How do we these are called calibrations. You understand? These are called calibrations. You have to know that what is for your time. You give a number here, one crore, and how much time it gives here. If you divide that, you know that how much. Let us say if 1 crore is so much of time, 1 lakh will be how much. You can calculate. These are all the typical. You have to do this in the embedded industry. Embedded industry is fully timing. Everything is timing. Okay. But if you run the same program in ARM controller, it may take only less than 1 second. That's a problem. That's a problem. Now let's on it on the on one. Then you see that I want to say once your time correctly. Since I given it, see now. Let us see. It should take about 28 seconds. Let us see. If it's taking 28 seconds, it's our calculation is good. Yeah, it take about 26 seconds. Correct. Now you know that it took about. If you give the more delay, then you'll get more accurate. Now think of it here. 10 1 crore is 26 seconds. So then you know that 10 lakh is 2.6 seconds and 1 lakh is 0.26 seconds. Understand now? So this is the one way. I'll tell you, no, this is not the accurate way. There are better methods are there. We're going to discuss about the better methods. Okay. Don't think this is a better method. This is a one method. Why I'm telling you this is for reason. I'm going to teach you how to generate the PWM using your own program. Am I right? So understand. Now I'm going to teach you. Erase this. Not required. Now we know that one information. One information is you have created for 1 crore 2.6 seconds. Sorry, 26 seconds. This is what you have calculated. Fine. This nobody will tell you. No documentation, nothing. That's only you have to find out. Now, if I ask you to generate 1 kilohertz wave, think that how much? 1 kilohertz. Am I right? Then your on plus off time together is how much? Think of it. 1 millisecond. 1 millisecond. Am I right? It is 1 millisecond. Now calculate. 26 seconds is equal to 1 crore. That is what you measured. This is you measured now. Just now you measured. 26 seconds is equal to this one. Now 26,000 millisecond is equal to 1 crore. Am I right? 26 millisecond. Simple mathematics. You should know how to use them. Now 1 millisecond is equal to 1 crore divided by 26,000. Strike. So 10,000 by 26. Okay, that is what you wanted now. That is what you wanted. Am I right? The pulse is 1 millisecond because 1 kilohertz. See that from frequency how I have come. So this, what is 10,000 by 26? That's a value you should calculate. So how much is? Let us take 25. That easy. 10,000 by 25 is about how much? 400. Am I right? 400 into 25 is equal to 10,000. So you get 400. So the total count is 400. That is this, on and off. So now you know that how do you calculate the time count? Now you have to say that you write a program now. Am I right? Now you write a program. Now let us write a program. For, now you say out equal to 1. While always there, while 1 is there. Now you output out 1. I will tell you at the end of the class. Now itself there's something interesting. You will be very surprised. And there is the thing called for I equal to 0, I less than 200, I plus plus, because we calculated 400. Now I'm giving 200 here. That means 0.5 seconds. So on time is I make 0.5 second. 0.5 milliseconds, sorry, 0.5 millisecond. Then off time, star out equal to 0. Then I make for I equal to 0, I less than 200. Now I make off time. Now once again on time, this loop. So you may think that how do you do that? There are so many methods. There's some simulators have a, some simulators have a this one scope or a logic analyzer. What is logic analyzer? That is a tool like a multimeter. Logic analyzer is a tool. That tool will show the waveform. Now let me tell you, let me explain to you now. Let me explain to you. I have a microcontroller. I have an output on bit 0. Let's say I have an Arduino Mega board or Arduino board, whatever board you use the board. Now your output. This output you connect to the logic analyzer. You connect the ground pin, and then this is normally black wire. Then there'll be a bit 0 signal, PWM signal. Now you connect here. This analyzer will show you the waveform. So you write a software, you can measure the timing, all these things. Actually, this will give you the beautiful idea of what you write a software, how do you control them. This logic analysis used to be cost about minimum of 10 lakhs initial days when we were doing the thing. Then it was coming to the price of 1 lakh. Today, you have a PC based logic analyzer. Less than 1,000 rupees. Think of it, less than 1,000 rupees. I will show you the like one product in the market. You can look at the product and I'll send you the link also. You can buy it from anybody. But when you start doing the hardware, you better buy this. That's a very important. It's a very, very important one. A tool which every embedded engineer should have it to see the waveforms. It's a very, very, very nice thing. You see that PC based. See, USB. We call USB logic analyzer. See, it's coming automatically. See here, it's costing even 570 rupees. Same one. This is what I'm trying to say. You see here. Even oscilloscope is available for about 1,000. We'll see that one. I've just opened the thing. See, just 700 how much rupees? You can take 8 signals, not only one signal. And it can go up to this one. It can see all the things. It cost about 719 rupees, 720 rupees, including GST. Actual price is 600 rupees. The GST is about 100 odd rupees. Am I right? Now let us see the thing. It's in a same, all are same one make coming from China. It's going everywhere. See here, the same thing here. It's available in everywhere. This is the same thing in US. That it cost about $20. Think of it. It's about $20 means 1,400 rupees. And you will be having a small wires. You can connect them. See, logic analyzer. You will be able to see that. Let's go to the image. Then you will know that. You will see that how it's code. This is a very, very nice tool for you, please. See, this is what you get it. See here. Now you see the image on the screen. This is the image, you get it. Please wait for a minute. It's coming. See here, this is the software. This software can be loaded on your net, logic software, and you will be able to see the waveforms. See here. I'll zoom it. See that now. See, you will be able to see that all signals, 8 signals, input 1 to 8. See, you will see all the timing. See what is the width, what is the period and everything. What is the frequency, all these things. What you don't get it in the college, you'll be getting it by buying this 719 rupees tool. Please understand. If you buy a board, if you buy an Arduino Mega board or Arduino board and have this analyzer, you will be able to do wonders. You will understand exactly the waveform. What is the output of the signal? Is it clear? Is it clear for you? That is what is the use of this tool. Never hesitate to buy this type of tools. It gives you the fortune. The moment you see the waveform, everything will be clear. Everything will be clear. You know that. Let us assume that. You may ask me that, sir. Everybody ask me like this, sir. I write a. I go to the board. These are all the tools you will be able to use later when we are going to discuss about I2C, SPI. Everywhere it will be useful. Okay. Now, if you write a small program for I is equal to 0, I less than 100, I plus plus. And you say, sir, if you ask me that, how much time this game will take? Nobody can tell you because that totally depends on the microcontroller or microprocessor. If it is an ARM, it will give you a different speed. The ARM itself at various frequencies, 100 megahertz or 500 megahertz. If you do that Atmel, 8051, every microcontroller, this small statement, if you write a small code here for I is equal to 0, I less than 100, I plus plus. Nobody can tell you how much time this guy will take. But now I am telling you the easy method. Easy method is connect a microcontroller pin to the logic analyzer. Okay, this is a bit 0, assuming. Now you say that out star out equal to 1. That means you make it on. Then what you do for I equal to 0, I less than 100, I plus plus. Then there's a delay. Then you say star out equal to 0. Also, you will find very interesting thing. I'll tell you some interesting things here. Those things are very, very nice. If you say CHAR, I, CHAR, now I'm declaring character. Of course, you give volatile. You give volatile. Otherwise, this game will do optimize. Volatile, char I. Sorry, I don't have a space. I write it here. Volatile, char I. Now you say star out equal to 1. For I equal to 0, I less than 100, I plus plus. Star out equal to 0. See here, you make 1, you make 0. What you get here is a small pulse. You measure the width. You will get the time, T. That is what the delay. That is what the time. Now you know that how much time this loop will take. But if you change the CHAR to short, 16-bit, the time will increase. If you take this guy to long, you don't change anything. You don't change the program, but you change the width. Then this timing will change. That's a trick. Am I right? You need to know that reason. See, these are all the you are getting into the embedded system. Now this is going to be your treasure hunt or that salary. That's all I say that. Now you should know that why these things are all behaving this way. But to understand that, which will be helpful to you, this USB based logic analyzer. I'll give you a small comparison. Then you will know that. When I joined HCL after my MTech, my salary was 1,580 rupees. How much? 1,580 rupees. I was a senior engineer. That is what a salary in 1987. But those days, the computer cost about 1 lakh. Computer cost about 1 lakh. And the logic analyzer cost about 10 lakhs. Think of it. So you cannot buy it. They used to buy it only in the colleges. There'll be only one piece in the college and in the companies. So these things will be only in the companies or colleges. Individuals cannot have it. But today, the average salary, I say average, 2-3 years experience or something, start about 50,000 rupees. I don't make a good engineer. I'm talking 50,000 rupees you make per month. But your PC is costing about 50,000. Roughly, you can buy a good PC. Also, the logic analyzer is costing you some 720 rupees. See that? 720 rupees. You go for a movie. Done. Am I right? But you don't know the value of that. If you like to make big money, in the embedded world, you have to do two things. One is C programming. I know that every one of you, not all the people, those who are listening now, every one of you just underestimate the power of C. You all don't know. You don't know the real value of C programming. Please, I will bet you. You people don't know, because you people are been very clear that I can solve the problem enough. If I give a problem, you think that, oh, I can solve the problem somehow manage and here and there, everything. But that is not we want. What the industry want is, You should solve the problem so naturally and in a quick time. This is a skill. But what you people think is that you are trying to satisfy me. Sir, I have solved the problem. But that is, please, I request you repeatedly, don't try to satisfy me. I don't want, you don't have to satisfy me at all, because this is your life. I am trying to help you, to guide you. This is your life. If you make money, you will be enjoyable in the future. You know that without money, nothing can be done in the world today. And you will make a big money. And the industry is looking for. That will come only by practice. That will come only by practice. How much time you practice per day or per week, it matters. The practice is the key. So I know that you underestimate this. That's the first one. Second one is, for you, there's a very good advantage of simulation. Start doing the project. Start doing it on simulation. Work day and night. Don't sleep, man. Don't sleep. When I was working in IIT, I slept for 2-3 hours. Never do that. Okay, don't put your effort. Put your effort on here. This will give you money. You are very young. This is the age you have to prepare for the money. Then, after simulation, invest on any board. I prefer to be mega board, because it has a lot of pins. You can do a lot of work. Or buy a board, Arduino. All I say, please don't think about, we know that you are using only the address pointers, car, star, out. When you start doing the pointers, all are same. Don't think that because of somebody says that industry, Arduino is a user. No, Arduino is a nice board. You need a microcontroller board, that's all. Arduino has a lot of advantage. You should be able to write a code, compile, download. These things are very easy in Arduino. That's why I say that do it in Arduino. And the boards are available cheaper rate in the market. Understand now. Then go to the actual hardware. The actual hardware, you will connect LED, 7-segment, everything. That is fine. But I wish you to connect to the logic analyzer also. This is another investment. But of course, certain simulation tools are having logic analyzer. You can try on that. Walkme is also having, but I've not yet tried. Let me try and tell you now. If you could able to do the simulation in the Walkme, then you are very happy. Let me do that. It is there, but not straightforward. Whereas in other simulation tools, it's available very nicely. Let me find out for you other tools, simulation tools. Understand now. So never underestimate the three. First one is C programming. Second one is simulation. I know that most of you are not understanding the power of simulation. It gives you to you night 12 o'clock. You can connect anything, a servo motor or stepper motor or a humidity interface controller or 7-segment or LCD. Anything can be connected and tested night anytime without spending single penny. It's only your skill. That means that you get a huge experience in the shortest time. That is the advantage of simulation. Then connect hardware with the logic analyzer. A wonderful tool is available for 720 rupees. Once you see the waveforms, once you see them on the screen, understand? Once you see them on the screen, the waveforms, you will never forget. And also, you will answer the questions in the interview so perfect. You will understand what is frequency, how to generate the clock using your software, and using the ARM board, what is the maximum speed you can generate. Am I right? So, but the beauty is you can do all these things right now. Because I've seen most of you have done a good amount of C programming. That C programming is really sufficient to get into this type of simulation and hardware. Okay, of course, that's not that is the only beginning. You have to go a long way in C programming. You might have touched only about 5% of my requirement, 5 to 10%. You people have to go big way in the C programming. But please understand, start today onwards, either morning 1 hour on wake up at 5 o'clock. Throw away everything, man. Throw away your laziness. I know that you people have a lot of other works, but I am telling you how to get the treasure. It's the money, man. And once you've done a simulation, once you watch a waveform and you apply any company, they're ready to take you. The companies are looking for engineers having this experience. If you say that you know logic analysis, you say that's very good, man. And you see the waveform of I2C or SPI and everything with about 720 rupees. Think of you. I'm not asking you to spend about lakhs and lakhs and about 4 years in your college life. You may not have touched logic analysis. But by spending 720 rupees, you will do wonders. Okay. Now, I'll come to why I told you the logic analysis. I'll come to the real point. The real point I'll come. What I did was I calculated using the my app, the stopwatch, the time. Am I right? That's what I did. Please don't take it very light, these things. These things, you don't get these things from anywhere. Nobody really understands the power of these things, which I'm telling you. Now, we have calculated this frequency. Let us say you are trying to make 1 kilohertz. 1 kilohertz means 1 millisecond is a time. And we have done that. We have done a calculation of 1 lakh count, was 1 crore is equal to 26 seconds. We use the stopwatch. But that can be done by a logic analysis also very nicely. Forget it now. Now from here, we calculate for 1 millisecond. We calculate the count is 400. That's what we calculated. Now you know how to calculate. 26 seconds is equal to this one. So 1 second is equal to how much? Then 1 millisecond is equal to how much? That's the way we calculate. This is the number we want. Because the software, you're going to use the number. This number is for on. Now the 1 millisecond equal to 400. Done. Now is a trick. Now you have a motor connected to the microcontroller. You have a motor connected to the microcontroller. Forget about, we have a driver to amplify that. Okay, that we'll discuss later. I'm not because that goes from analog and not transistor and everything. That's why I didn't discuss now. Right now we do it like this. And this is a 5 volt. This is 5 volt. And this is 0 volt. Now, this motor runs at 1000 RPM. There's a table. If you give 5 volt, that will give 1000 RPM. If you give 1 volt, that will run about 250 RPM. 4 volt, about 750 RPM. 3 volts, 500 RPM. 2 volts, 250 RPM. 1 volt, say 100 RPM. See that. This is what the way the motor. So, if I have a battery, if I have a resistor, variable resistor, then it's a 5 volt. I remove this. So understand, I have a battery, I have a resistor, I have a motor. If I change a resistor, then the voltage will change here. So the motor, if I give 1 volt here and 4 volt here, then the motor will rotate at 100 RPM. That is what you are doing in the fan. The fan, you are controlling this regulator, so you are controlling the current. So the voltage is changing. So because of the voltage is changing, we do that. Now, what we are doing here is we control the voltage using this pulse. This is called PWM, pulse width modulation. Any voltage can be generated. For example, if I say for, think of it. If I write a program, see, think 1 minute. This is a microcontroller output. This is software. While 1, star out equal to 1. I make it on. I say for I equal to 0, I less than 200, I plus plus. So 200. This is 200. Then star out is equal to 0. This is off. Then I say for I equal to 0, I less than 200, I plus plus. Understand? Now what happened? This is 0.5 milliseconds. This is 0.5 milliseconds. What is the duty cycle? Duty cycle is 50%. How? T on. This is T on. This is T. The whole time is T. This is T on this time. T on by T. Now T on is 0.5 seconds divided by 1 second. 0.5 milliseconds by 1 millisecond is equal to 0.5 is equal to 50%. Since this 50%, your voltage is 5 volt. The pin will get 2.5 volt average voltage. So if you connect a motor, it will rotate in between that, maybe about 350 RPM. Suppose I want to make it 100 RPM, then you change the delay 1 and 400. Sorry, 80 and 320. See that I don't change the 400. The 400 is same. Now I change the time here 80 and I change the time here 320. So totally 400. But what is the duty cycle? Now 80 by 320. Sorry, 400 by T, not T off. This T off. The T is 400. That does not change. So 80 by 400 is equal to 1 by 5 into 5 volts is equal to 1 volt. 1 volt is 100 RPM. See, this is the thing you have to understand. By using this loop, I could control the voltage output of the device. This is a digital. This is digital, 0 volt and 5 volt. But now I am controlling the voltage. You'll be very surprised. If you connect the LED, that's what yesterday I showed the LED also. If you connect this, the LED will be dim. I can make this guy, I can give you the sum like this. Let us take a challenge. I want the LED. Let me give you the sum very clear. I want the LED to start initially off and it will slowly become bright. Then it will slowly become dim. From off to bright, it should take 1 second. From off to bright to off, it should take 1 second. Everything is timing. If you know everything, how to adjust the time, then you are a good embedded programmer. All the electronics people should know about timing. All the 1 millisecond, 0.5 milliseconds, everything T on. These are the ones the computer science people run away. This is the one advantage you have it. You understand the volt. You understand the time. This is called, typically the timings are called AC characteristics. And the voltage is called DC characteristics. That's what I write it on the data sheet. So what I'm effectively trying to say is that now you got to understood a motor, PWM, and the relation with the software. Using software, I don't use anything else. I'm using the simple while loop This is all level 1 commands. Level 1 in C programming. I don't even use array. I don't use pointers. I don't use strings or anything. I'm just using the while loop and a for loop. That's all. Am I right? There's nothing great, but you can control the motor. Okay, I'll give you about time, about 2 minutes. You can ask me any doubts if you have. Is it clear? People have now you should say that. If you say that you don't understand PWM, you can tell me I don't understand PWM. Please let me know. If you tell me now I don't understand the relation between PWM and motor, I don't, then you can say that, see, I'll once again list it out very clearly, everything one by one. Then you will summarize it. I want to summarize the whole thing. What is PWM? A pulse width. This is pulse width modulation. Like you would have studied in the college, AM, FM, PM. Analog modulation, frequency modulation, phase modulation. This is pulse width modulation. So just making a switch on and off, okay, I could control the voltage very nicely. No, very clear. Now I'll somebody ask, very good. That's the question, very clear. See, that is what we are discussing. See here, please understand this very clear. So this is what I expect. See, if you don't understand, ask you, I don't understand. There's nothing wrong. It's only we are there. Now I have a pin. Understand? I have a pin. This is the pin is going to give 5 volt. Then I put a resistor. I assume 5 volt. Then I have a LED. The LED will take 2 volts. The LED will take 2 volts. So I have to drop the remaining 3 volts here. Am I right? So the current through the bulb is 10 milliampere. Then only the LED will give you the brightness. That is called rated brightness. That's rated. That means in your house, if you give a 230 volts, your fan will rotate the right speed. If you give 200 volts, the fan will rotate slower speed. If you give 110 volts, 100 volts, it will be still slower. So this is called rated voltage. Of course, from next week, we're going to discuss about electrical. That time you will be having a, from Monday onwards, we're going to start discussing about electrical. Then you will know that. Now, the trick here is, what we do generally is, we take a battery, we put a variable resistor called regulator and change the resistor. When I change the resistor, then the voltage across there should change. How? That is the trick. Now you see here, instead of 5 volt, if I give 4 volt, what happened? This will become 2 volt because this get 2 volts, this get 2 volts. The resistor is how much now? Previously, when I give 5 volt, this is 300 ohm. So what is the drop here? 3 volts. Totally 5 volts. 3 volts here, 2 volts here. Because both are in series. So 3 volts divided by 300 ohm is equal to 10 milliampere. So the current I is equal to 10 milliampere. So the bulb, the LED is going to give you the some amount of resistance. Now, if I change the voltage to 4 volt, what happened? Here 2 volt, here 2 volts get dropped. So 2 volt divided by 300. How much? About 6.67 milliampere, not 10 milliampere. So the LED will be little bit brighter. If we make this as a 3 volt, this drop here become 1 volt. 1 volt divided by 300 equal to 3.3 milliampere. So if I change the pin voltage, then that guy will drop. How do I change the pin voltage? We do this one, while loop. While 1 out equal to star out is equal to 1. I make it on. For I is equal to 0, I less than 200, I plus plus, star out equal to 0. For I is equal to 0, I less than 200, I plus plus. Now you see that on. Now what I'm doing here is this place. I make the on time, I on and off. I make the pulse. I on and off. This time is going to be 200 plus 200, 400. But this is 200, this is 200. So the voltage what you get here is 2.5 volt. Understand now how I am controlling the voltage. Now if I change this one to 100 and 300, see here, 100 and 300. So this is 100, this is 300. Now what you get here is 100 plus 300, 100 by 400 into 5 volt. So I get about 1.25 volts. So the LED will not glow. It requires minimum 2 volts. Now if I make this guy, what? If you make this guy as 300 and 100, then what happens? Totally 400. But what is the duty cycle? 300 divided by 400 into 5 volt. So 3 by 4 into 5 volt is 3.75 volts. This calculation you should do practice at your home. This calculation, if you don't practice at your home, you don't get it. I told you yesterday itself, watch these videos. That is what I'm trying to say. You write a software to control the voltage. That is the advantage of PWM. By changing the duty cycle, of the waveform, you'll be able to change the time. Now you have to use the for loop, better programming to find out that what I want is I'll tell you what I want. If you can able to make it fine, see that I connected the LED. I can write and show you, but I don't want to do that. If you do that, then you will never learn. I want the LED to go from off to bright, then bright to off. You have to know simple programming. Only level 1, that is declaration, assignment, operators, and for loop, for and while loop. Declaration, we used about int, and assignment we used about decimal, and the operators we used about addition, subtraction, multiplication, division, and modulus, and for while loop. This is sufficient to make this program. If you could make this program, then I know that you understand good in programming and good in loop and good in PWM. Once you have done this, then I will explain to you that how to do the what do you call it? Controlling motors, much more than that. We'll discuss more and more. There were about lot of motors are there which we are going to discuss. Right now I'm discussing about just simple DC motor. In DC motor itself, I discussed about just a simple PWM, but I have to discuss about the driver circuit. Then I have to discuss about direction control. Then we have to discuss about what is torque. Torque versus speed. You know that when you are driving a bike, when you have a car, you have first gear, second gear, third gear, like that. Why do you have so many gears? What is the relation between torque and speed? Okay, those things have to be understood by us very clearly. Otherwise, you will not be able to do perfectly embedded. Then, after DC motor, next thing is stepper motor. The next to stepper motor is servo motor. So this also PWM. They are very easy, not very tough. But I'm trying to explain to you that simple concepts, but we cannot proceed further on this concept. And